PhaseLine function draws a graphical representation of the phase line or phase portrait for a first-order autonomous differential equation of one variable. So it'll take in this function, which is now only a function of one variable because it's autonomous, it does not depend on t explicitly, and draw the phase line for it. Let's look at the function real quick. And so this has three inputs, f, a y min, and a y max. It doesn't have any outputs, so it's just going to draw the graph. And so what this will do is it'll take the function f of y, which is an autonomous function of only one variable, because we know this does not depend on t. It takes in a y min and a y max for the lower bounds on y respectively, and it will draw a representation of the phase line from that. So let's look at an example for this. I could look at drawing the phase line for the function of one variable given by the following over the range of -5 to 5, and then I could run that. And there is a picture for the phase line. Blue or red mean up or down. It'll be up to you in the Matlab assignment to determine that. But there's the phase line. You have black for the equilibrium solutions, and then blue and red in between them. Now note that this requires a function of one variable to run. But the earlier functions, however in sample plots, require two variables. How can we get around this? Well, we can make new functions related to the other ones to make all this work. Let's see an example of what that might look like. So say I have a function g, which is my autonomous differential equation. It is just a function of y, and we'll make it simpler this time. It's just y and y minus 2. That's the entire function. Now, I can draw the phase line from this function here. That will work just fine. There it is. Now, what if I want to do sample plots with this? Well, I can do that, but there's a problem here. And the problem is, sample plots requires a function of two variables to work properly. So how do I get a function of two variables to put in there? Well, I make a new one. I make a function that is a function of t and y, because that's what sample plots needs. And I just say this function equals g of y. So this snippet here is going to make a new anonymous function of two variables, where for every value of t and y, it just computes g of y. It doesn't care what t is, it's always going to be the same value, which is right because this autonomous differential equation doesn't care about t either. So this will now give me the sample plots for that function, because now this knows what to do because it's a function of two variables. I just picked 0 and a bunch of values in initial conditions. We can then run this, and we'll see that worked just fine. We got the phase on like we wanted to before, and now we also got the sample plots here as well, because we were able to make the function of two variables, so sample plots would actually be able to run on this information. You could run Quiver in the same way, it would do the exact same thing as sample plots there. And that just goes to show you that you need to make sure you have the right type of function with the right number of variables whenever you call any of these methods to make sure they will work properly. You'll get some weird errors if they don't. For instance, if I were to just ignore this part and just put g in here and try to run that, it's not happy. Right, too many input arguments because it is expecting a function of two variables to show up. It's only seeing a function of one. So that's the kind of errors you're going to get if you put the wrong function in the wrong spot. I fix it, we're back to being good again. There's the phase line function, how to make it work to sketch pictures of phase lines for autonomous differential equation.